Okay, your lesson today is on the surface area of cylinders, cones, and spheres. The last lesson that I taught you was about solids that have planar faces. Another word for planar just means flat. You may remember from that lesson, there wasn't a specific formula for objects that had planar faces. Can someone remind me, what was the strategy that you used to work out the surface area on the outside of something that had flat faces?
And the areas of all the surfaces.
Yes. So you work out what shapes the surfaces are, and then you add them together. If you missed that, if you're away, video's up on last lesson on Damo. Now, there are solids that have curved surfaces like cylinders, cones, and spheres. They have a specific formula. I wasn't your teacher last year. Does anyone know what the formula for a cylinder was off the top of their head? You don't have to. It's not going to be.
Pi r squared times 2 plus the rectangle.
Okay. 2 times pi times r squared. Sorry, what else did you say?
Plus diameter times width.
I've got a better way to draw it. Just 2 pi times r times h. There is a reason for that. Hopefully, pi r squared is familiar to you, because one of our particular students told me pi r squared was the formula for what? A squircle. A circle. How many circles exist on a cylinder? 2. This here, if I come 2 pi r is actually length times by width. Because can someone tell me what shape, if I was to cut that tube part of a cylinder and laid it flat, what shape would it form?
Rectangle.
It'd be a rectangle. This is a rectangle that I've rolled into a cylinder. What can I say about the exact length of that rectangle? It is the something of a circle.
Circumference.
The circumference of a circle. And what is the formula for the circumference of a circle? 2 pi r, or our intelligent student here said pi times by diameter times by h. That works too. Multiple ways to get the same answer if you know all the way across the circle. So add the little arrow here. If I did a dot to the edge, that would be the radius. If I did a line all the way across, what would that be? The diameter, which is d. Where would I draw a line to represent the h in the formula? Horizontally, vertically what? Vertically, I already have a vertical line. The height of the cylinder is this. That's your h. Those are the things that you need to know to find the surface area of a cylinder. And if I break it down to it, these are the 2 circles. And this is the rectangle. That is a cylinder. Get that down, please. So let's do a similar thing with the surface area of a cone. Let's break it down into the shapes. Because this was 2 circles and a rectangle. No. What's on the bottom of a cone? So we already know that there's going to be pi times by radius squared somewhere. That covers the bottom. But does anyone know what shape forms the cone on the top? Maybe a circle? Let's try. I'm going to cut.
No, it's a circle.
Sorry, I want to do it live because it makes more of an impact if I do it live. That's a circle. What's special about a cone? Is a cone 3-dimensional?
Yes.
Is this ever going to be 3-dimensional? So what forms a cone is this? A circle with a cutout. Okay? Unfortunately for you, I know what the area of the cutout is. The cutout is pi times by r times by S, and S is the slant here. So this is S, this is the radius. That's all you need to know to find the area of a cone. Just to illustrate it, I'll do a net. That shape, the cone shape, is actually, have you heard of that game Pac-Man? It's like one of the first games ever made. It was a circle with a little cutout. That's what forms this to make it three-dimensional. Because I think I proved to you that a circle is always going to remain a circle unless it's got that cutout in it. Okay? So what is this? This is the circle on the bottom. And this is the Pac-Man shape that forms the cone. So you need to know the slant. That's tricky. The example I'm going to do is going to test you with that. I need to know how long the diagonal side of it is, not how tall it is, not how wide it is. So I need to use something starting with P to work out how long that is. Any ideas?
Pythagoras.
I'd use Pythagoras if I didn't know how long the slant was. Lastly, spheres. Unfortunately, I don't have there's no good demonstration that I can do in front of you to show that a sphere has a surface area of 4 times pi times radius squared. A sphere on the outside is just 4 circles worth. I wish I could demonstrate that with paper and stuff, but I can't. So you just have to take it as a given. What do I need to know to find that? I need to know the radius. Can you get that last one down, please? And then we'll do an example. Is anyone still on this board?
No.
Have a think about how you would find the surface area of this shape. Please remember, surface area is the total external. What is another word for external? Outside. Surface area is the external area of exposed faces. If you have an object made up of multiple shapes, you may need to subtract faces that are not exposed. Is there a situation like that here?
Yes. C.
Okay. Surface area of the sphere. We'll shade it to make it look like a sphere. Do I know the radius of this sphere?
Yes. Yeah.
No?
Well, not really, but like you do.
But you can work it out.
Yeah.
You know the diameter.
You know the diameter, so half of it is the radius, so 4 times by pi times by the radius, which is 4 squared. I asked you to get your calculators out to help me out. I can't times by pi in my head. So, according to BEDMAS, what would I have to do first? I need to do 4 squared first because it's an exponent. So 16 times by pi times by 4. Someone help me out, please. I'll do as well to make sure.
201.06.
Yeah. 201.06. What units would that be in? Would that be in centimeters?
Squared centimeters.
Square centimeters. Because we're talking area now, we're talking length. Here we have the surface area of a cone, shaded as well. What was the formula for the surface area of a cone?
S. Yeah.
You just wrote it down. Pi r squared plus
I asked about plus.
pi r s. Do I know s?
No. No.
Do I know how long the diagonal bit is?
No.
No. Yes?
No.
No. Can I work it out? How tall is it from the top to the middle of that cone? 6. How long would it go from the middle to the edge?
4.
4. Does that form a right angled triangle down there?
Yeah.
So, according to Pythagoras, s squared is equal to 4 squared plus 6 squared is equal to 16 plus 36. 16 plus 36, 46, is that 52?
Yeah.
What's the opposite of squaring something? If you're doing methods next year, you're going to be encouraged to leave everything as roots. Because we're in year 10, we're just going to work that out in the calculator. Square root of 52, 7.21.
That was my next guess.
Huh? Do I have what I need now to find the surface area of the cone? I need to do some little work off to the side. So, pi times pi, what is the radius of the cone? 4 squared plus pi times by 4 times by 7.21. You're not being tested on this, you're doing an assignment, so you take your time. Don't stuff up. Are there a lot of numbers here that you could actually type incorrectly? So check that you're typing it right. 4 squared times that by pi is 50.27 plus, do them separately, pi times by 4 times by 7.21, 90.60. Now, I've already spoken about being smooth brain and rough brain. Is there something I could do to make sure that I'm not doing work that I don't need to do? Is there a part of this that I'm not going to include anyway? Because I'm finding the surface area of this shape. Yes?
You only need to figure out one of the circles.
Well, we're talking about the cone right now. Yeah?
You do need to figure out the base of the.
Yeah, exactly.
Yeah.
So I'm not going to mark you down if you don't bother going pi times by 4 squared. I'm only showing that because is this the formula I gave you? But remember, it's the surface area, so I don't need to consider this because that's the circle at the bottom of the cone. And is that exposed? No, it's just sitting. It's sitting in the joint. And also, if you're thinking ahead, if I'm finding the surface area of this, and the formula I've given you for the cylinder includes 2 circles, do I need to find 2 circles worth?
No.
Because is this circle on the top of the cylinder exposed? No, I only need 1 circle. Okay, so 90.6 square centimeters. Let's do the surface area of the cylinder equals 2 times by pi times by radius squared plus 2 times pi times radius times by height. Now, because you're being smart about it, do I need the 2 in front of the circle? How many circles are on this cylinder exposed? Only the bottom. So now we're going to break it down. Pi times by radius squared plus, I still need to do the rectangle. What's the radius of the cylinder?
15.27.
That's not what I asked. 50.2. The radius of the cylinder is 4.
Exactly.
Pi times by 4 squared plus 2 times by pi times by 4 times by... How tall is that cylinder?
10.
10. So load up your working out and then work it out all in one go at the end. So pi. Do you actually know... Have I already written down what the area of this a circle is? I've got that working out there already. I'm not going to waste time on the calculator. It's 50.27. 50.27 plus, the only thing I need to work out is that 2 pi RH. 2 times by pi times by radius times by 10, 251.33. Two 251.33 plus 50.27. So the grand total of the cylinder is 301.6 square centimeters. Underline that because that's part of my working out. Underline this because that's the cone shape of the cone. Underline the sphere. If I've underlined all those, am I making an assumption about how the cone joins with the sphere? Yes or no? Have I said that there's any joint? No, we're just assuming it's joining at a point. Just a heads up, that's something that you can talk about in your assignment coming up. Because We're simulating possible real life scenarios using maths. Could this exist in real life as drawn? Are you sure?
No.
Literally just balancing somehow on a wing and a prayer?
For a brief moment.
For a brief moment, possibly. Yeah.
Windmills.
So what would I need to do with those underlined numbers? Add them together. So total, put a box here, total SA is going to be square centimetre. Can you get that example down, please? I'll stop the recording now.